Hello everyone, welcome back to this session. We'll quickly cover the topic models of neuron. In the last class, we saw these two topics. Now we have this model of neuron. Okay, so see, model of neuron, like you have to talk about a neuron. What is a neuron? It is an information processing unit. Always remember, a neuron is basically something which takes the electrical impulses as an input, as synaptic weights. It converts that electrical into chemical. That is actual brain thing. But in the subject, it's information processing unit which takes the synaptic waves as input, processes it, takes some bias, all the weights calculation, and then after the activation function, it gives us the output. Okay, so see here in basic, I'll show you in this diagram. These are all the input values along with some weight. Input and then weight. All these weights are added in a summoning junction. For example, suppose we all students, we have some knowledge. We are gathering in seminar hall. So all students have been gathering in the seminar hall, and then there is a bias BK. That is nothing but how the seminar in like a speaker, a motivational speaker, or the person for which the event was organized in the seminar hall, and then we have the principal who starts the function and then it continues, we get the output. So that's what it is. If you read the explanation, I mean definition now, you will understand. A neuron is an information processing unit, nothing but a building block of a neural network. So building block of neural network is a neuron. Okay, it takes many input signals. We saw that x1, x2, so on to xm. Decides which input matters more using synaptic weight w1, w2, so on up to wn. Combines them using a summoning junction. That is add. That is summoning is nothing but the summation junction, denoted by u of k. You can say u of m also. Adjust a decision boundary by bias. Okay, and finally produce an output using an activation function. Okay, so here this omega thing you see is our activation function. V of k bias is b of k. Then what bias along with this uk, so uk plus bk is nothing but this vk. Okay, then that gives us that is sent to the activation function. There are types of three activation functions depending on the value of v sometimes, or the conditions. We'll say you understood, right? So the process is what is happening. Synapses or the connecting links with weights. So this is nothing but this. Each input x is multiplied. So whatever x is there, it is multiplied with its respective weight, x1 into w1. So all these values, input value with this weight, is being added over here. Positive weight effect, executatory effect, negative weight inhibitory effect is nothing but the actual activation for the neural network. If the value is negative, it decreases the chances of activating. If it is positive, it increases like that. Add a summoning junction, just see linear combiner. Then you have a activation function called squashing function because it limits output to a finite range. In the sense what? So the output values, it's the range between which the output might give. So 0 1 means the output will be either 0 or 1. If it is minus 1 to 1, so output can be minus 1, 0 or 1. Bias bk shifts the active function. So bias is something which forces the actual flow of this function or the operation to get some changes. So it's not like static, it makes it flexible. So up down left right, that kind of thing. Then we have steps what happen inside. See uk, so all the weights, summation of j is equals to, this is j, okay, equals to 1 to m. So all the weights have been multiplied from 1 to the last number of weight, that is j. You can actually take it as m as well. So they have been multiplied, and then collect all the evidence after giving importance. Then we are add what to say, we got uk. So uk equals this. Now we are adding bias to this uk, that becomes vk. And then now activation function. So what the output is equals to activation function of this vk over here. This is sent over here. I say, why do we need bias? Like I said, it makes a changes in the flow of the operation, then shifts the decision boundary left, right, up, down. Oh, that's bad. Okay, so then bias has an extra. So let me underline because when you read the notes, it might be helpful for you. Okay, so here bias is an extra input. This is exam favorite point. You shouldn't write this in the exam because this is for us to understand. That is exam favorite point. What is happening here? Here, instead of the value of weight, we are taking bias itself as a value of weight. So now what happens? We don't have to add bias separately. So we can take bias directly as a weight, and each x and w will be multiplied. Here already bias is there. See, this bias is already here. Be like b k1 k2 so on to kj, like that. And then same thing here. Okay, types of activation function. Here the value which we get over here by after multiplying, or I mean adding all the values and then adding the bias. If v of k value is, see here, greater than or equals to 0, then activation function is 1. If it is less than 0, it is 0. That's it. Sigmoid logistic. See, 1 divided by 1 plus e to the power of minus a into v. So here output becomes smooth probability like value between 0 and 1. Let us go to the textbook. See here, this is here we have 1 divided by 1 plus exp. You can write x e to the power of minus av or exp of this, like that. So a slope parameter, by varying the parameter a, we obtain the sigma function. So see here the diagram, you can see over here like how the S shape they are talking about. It's here, okay, it's like that. Then he, as a goes towards infinity, sigmoid is similar to the threshold, like reaches approximately reaches the threshold value. Keyword differentiable, important for learning backdrop. Then extra, if as in exam, signum function and tanh function. Activation function is equals to plus 1 if v is greater than 0. It is 0 if v equals to 0, minus 1 if v is less than 1. So let it's here, see, very simple. Sorry. See here, if v is greater than 0, the activation function is 1. If it is equal to 0, 0. Then if less than 0, minus 1. Very simple, right, to understand. Then you have tan h. It is simply equal to tan h of actual v. Okay, that's it. So neural network directly grabs the next topic, and we'll see this in the next.